Hello my dear students, once again welcome to your online class. In this video, we will be discussing about the chapter sound of your physics textbook. So now to begin with the chapter sound, you all already know that the sound is a form of energy. Now which form of energy? The sound is that form of energy which produces the sensation of hearing in our ears. Okay, so sound wave, it strikes our eardrums and then we hear the sound. Now this sound is produced by the regular vibration of an body. So by the term vibration, you all understand that the rapid to and fro motion of a particle is said to be vibration. So whenever something moves to and fro, just like when you pluck a scale or when you pluck a string or a rubber band, okay, so all those when it starts vibrating, okay, that is moving to and fro about its mean position, then it is termed as vibration, and this vibration, it produces a sound. Now the sound, unlike light, the sound is a mechanical energy. So what do you understand by the term mechanical energy? So we have the sound is a mechanical, not mechanical energy, it's a mechanical wave. Okay, so the mechanical waves are all those waves which requires a medium to propagate. Okay, unlike light, the light can travel even through a vacuum also, but the sound, it cannot travel through the vacuum. It requires some medium like either air, water or some kind of solid. Okay, so the sound is a mechanical wave. Now again, these mechanical waves are classified into two types. The mechanical waves usually classified into two types, one being a transversal and another being the longitudinal. Okay, so the transversal waves are the one in which the particle vibrates perpendicularly, or we can also say normally, to the direction of propagation of wave. Just like transversal wave, if the sound is moving from A to B, okay, and if this medium contains various particles, these particles will vibrate in the direction perpendicular to the propagation of wave. And coming to the longitudinal wave, the same, if it is moving from A to B and these various particles present in the medium, it vibrates along the direction of the wave, that means to and fro, and here it's up and down. The sound is a mechanical wave, and in mechanical wave also it's a longitudinal wave. Understood? So that is about the nature of the sound. Now coming to the requirement of a medium for the sound wave to propagate. So there are three requirements for any medium to allow the sound wave to pass through it. So the first one is the medium must be a elastic medium. So it must be elastic. Elastic in the sense we understand that the medium, it should, like the particles of the medium, after vibration, it should be capable of coming back to its mean position. That means it should come back to its original position. Okay, so that is said to be the elastic. So the second is that medium, it also must pose the inertia. Okay, so inertia we have already discussed in the second chapter. What is inertia? So it must have an inertia to store the mechanical energy in it. And the third one is the medium also must be frictionless, so that the sound energy or the particles, they can vibrate very easily. So the three requirements are the medium must be elastic, it must pose some inertia, and the medium also must be frictionless. Now coming to the first, let us discuss about the speed of the sound in different medium. So the sound, it travels fastest in the solid. So the velocity of sound in solid is fastest, and then lesser in the liquid and least in the air. Okay, so in the air, the sound, it almost travels with a speed of 340 meters per second. Okay. But when we come to the speed of the light, we know that it travels with a speed of 3 into 10 to the power 8 meter per second, which is much more faster than the speed of the sound. Okay, so while comparing the speed of the sound with the speed of the light, the speed of light is much more faster than the speed of the sound. Now moving on to the next topic, the different terms related to the sound. frequency, wavelength and the wave velocity. Now if I consider the sound in the graphical form, okay, the propagation of sound. So if I draw the sound wave, okay, so the first is frequency, so which is also denoted by the letter small f. So what is frequency? The frequency is the number of complete oscillations made in 1 second. Just like if you hold a scale and if you plug it, if in 1 second, if the scale moves 20 times, we can call its frequency is 20. Now coming to the second one, the wavelength. The wavelength is the distance traveled during one complete oscillation. So the wavelength can be denoted from the point O to point A. Okay, so this distance is said to be the wavelength, which is usually denoted by the letter lambda. Okay, and coming to the third one, the wave velocity. So the wave velocity is the distance traveled by the sound wave in 1 second. And now there exists a relation between the frequency, wavelength and the wave velocity, which can simply be given by V is equals to lambda into F. Okay, so this is the expression that relates the wave velocity with the wavelength and the frequency of a sound. Now coming to the fifth topic, that is the factors on which the speed of the sound depend. So usually there are 4 factors on which the speed of the sound depend. The first one being the temperature. With the increase in the temperature, what happens? So the first one is the temperature. So with the increase in the temperature, the velocity of the sound also increases. Okay, so the velocity of the sound is directly proportional to the temperature of an environment. So the second factor on which the speed of the sound depends is the speed of the wind. Not speed, we call is the direction of the wind. Direction of wind. So if you speak or if the sound travels in the direction of the wind, then the speed of the sound increases, and if the sound wave travels against the direction of the wind, the speed of the sound usually decreases. The third factor is humidity. So what is humidity? The humidity is the quantity or the amount of water vapor present in the atmosphere. Now since we know that the speed of the sound is greater in liquid, so therefore the presence of water vapor in the atmosphere, it results in the increased speed of the sound. So the third factor on which the speed of the sound depends is humidity. And finally the last factor on which the speed of the sound it depends is the density of a medium. Okay, so higher is the density of the medium, the lower will be the velocity of the sound. Okay, so these are the 4 factors on which the speed of the sound depends. Now coming to the sixth one, it's very simple. Usually the question comes that, not question, it's a practical life experience that when it's raining, when the thunder and lightning occurs, what happens? We see the lightning first and then after a few seconds we hear the sound. It's very simple because the speed of the sound is much more faster than the speed of it's because the speed of the light is much more faster than the speed of the sound. So that's why we see the lightning first and then after some time we hear the thunder. Now coming to the final topic, that is the classification of sound. The sound, it can be classified into various types depending upon its frequency. So the sound wave can be classified as a audible sound and inaudible. Okay, so audible and a inaudible sound. Audible sounds are the one which we can hear and the inaudible sounds are the one which we cannot hear. It's very common that we do not hear all the sounds. When you see the leaves moving on a tree, we do not hear the sound. The leaves are moving, and in the beginning we learn that whenever something moves, it produces a sound. But in spite of that, we are not able to hear that sound. It's because the frequency of sound is very less. So the human being is capable of hearing a sound only between the range of 20 hertz to 20,000 hertz. Okay, so only in this frequency we are able to hear the sound, and that is known as a audible sound. It's also known as a sonic sound. Now if something vibrates less than 20 times, or if any sound wave which has a frequency of less than 20 hertz, we are not able to hear a sound, and that sound is known as an inaudible sound, and the sound whose frequency is less than 20 hertz is known as infrasonic sound. Okay, so infrasonic sounds are the one whose frequency is less than 20 hertz. And even if something has a frequency more than 20,000 hertz, we won't be able to hear the sound, and that sound is known as ultrasonic. Ultrasonic sound. Okay, since this ultrasonic sound has a higher frequency, so it carries a higher energy, so therefore the ultrasonic sound can be used for various purposes. And finally, we have one more term which is known as a supersonic. Okay, so supersonic does not refer to any class of sound, but the supersonic refer to the term that travels with the speed of the sound. So if anything traveling with the speed of the sound, we call that it has a supersonic speed. So there are various aircrafts nowadays that travels with a supersonic speed. Now some of the few important topic that is to be discussed is the reflection of sound, music and noise pollution, and the ways to prevent the noise pollution. So coming to the reflection of sound, just like the light, it gets reflected by a mirror or any plane reflecting surface. So similarly, if there is a huge obstacle, okay, in front of a sound wave, the sound wave also gets reflected back, and the reflected sound is known as echo. Okay, so you must have heard this echo when you are shouting when in front of a big obstacle which is a bit far away from you. Now it's not that you will be able to hear the echo all the times. So there are some of the necessary conditions required to hear an echo. So the first being the distance. Okay, so the distance between the source and the obstacle must be minimum 17 meter. That means from a huge obstacle you have to stand at least 17 meter away from it. And the second one is the intensity of the sound. Okay, so you must shout loud enough so that that sound energy may not get dissipated in the atmosphere itself. So the intensity of the sound should be large enough. And the third one, you can also take about the size of the obstacle. Okay, the size of the obstacle also must be large enough. Like if you place a copy 17 meter away, obviously you are not going to hear an echo. Okay, so that is what is meant by echo. The reflected sound is known as echo, and then there are some of the conditions to hear an echo. The first being the distance must be 17 meter, the loudness of the sound should be greater enough, and then the size of the obstacle should also be large enough. Now coming to the another topic, the music and the noise. So you are very much familiar with the music and a noise, but this music and a noise is a subjective quantity. Okay, so it depends upon the person who is listening to the sound. Just like for a few of you, the rock music, okay, or the heavy metals, they may appear as a music, but the same thing to our grandparents, it may appear as a noise. Okay, but the basic difference between the music and a noise is the music is produced by the regular vibration of an body. Okay, and the noise is produced by a irregular vibration. You already know the music, playing of a guitar, string, drum, but if you play the same thing, okay, unperiodically, then the same thing can be said as a noise. So noise is the continuous disturbance which is produced by the irregular vibration of an body. So now coming to this topic, noise pollution. So what is a noise pollution? The unwanted sound that creates a headache or some tension in humans or in the animals are known as noise pollution. So sudden intensity of the sound, when it crosses that intensity, then we term it as a noise pollution. Okay, so the noise pollution has a many side effect. Okay, the first one being it disturbs us, it causes damage to our ears, sometimes even the permanent damage as well. And what can also, the noise can also cause tension, okay, in humans. So therefore there must certain measures must be taken in order to avoid this noise pollution. So the first, if you are listening to the music, please lower down the volume, okay, because you may want to hear to that music, not your neighbors. Understood? So, and the vehicles, it must be fitted with a proper silencer system. But nowadays the people, what do they have? They have a habit of making the motorbikes or making some changes in the motorbike that creates a louder sound. So all those things should be avoided, and as well as the trees can be planted along the roadside so that that the trees may absorb the sound and then the noise pollution may get reduced. So this is the end of the chapter sound. So dear students, please go through the video and then I will send you the solutions of the questions of your exercise. And if you have any problem, you are always free to ask me in my WhatsApp number. Thank you.